Welcome to our lecture online. Now let's try an example of type 2 where the function is not defined over the entire interval. The function, the natural log of x, is not defined when x becomes equal to 0 because the function asymptotically reaches the y-axis. Well, it never quite reaches the y-axis, approaches the y-axis, so therefore it's not defined. It's basically a vertical asymptote. That's why we need to solve this equation or this integral using the limit approach as t approaches the limit 0. Let's work out the problem where we ignore that advice and simply try to do it directly like this to see what would happen. So let's go ahead and try to integrate the natural log of x dx from 0 to 1. Of course, we need to use the integration by parts technique. The integral of u dv is equal to u times v minus the integral of v du. And in this case, we're going to let u equal the natural log of x, which means that du is equal to 1 over x dx, and dv is equal to dx, so that means v is going to be equal to x. All right, now we're ready to integrate. So this can now become the following, that is equal to u times v. So v is x, u is natural log of x. That would be x times the natural log of x, evaluated from 0 to 1, minus the integral of v, which is x, times du, which is 1 over x dx. And again, that would be from 0 to 1. And notice that this x cancels out that x. And so this would be equal to x times the natural log of x from 0 to 1 minus x from 0 to 1. And now let's plug in the limits and see what would happen. So this is equal to, plug in the upper limit, 1 times the natural log of 1, which is 0, minus 0 times the natural log of 0, which is undefined, minus, plug in the upper limit, we get 1, and subtract from when we plug in the lower limit, we get 0. So the natural log of 1 is 0, so this becomes 0. This portion here is undefined. This here would be minus 1, minus 0, or this here becomes a minus 1. So we have a problem. This portion is undefined, so we have to find a way to evaluate that. And so we're going to do it the proper way by putting in the limits t as t approaches 0. So we're going to get the very same result as we have here. So this integral now becomes equal to x times the natural log of x, evaluated from 0 to 1. And of course, we have to plug in the limit. The limit as t goes to 0 of, and instead of 0, we're going to use t. And let's see here, then it gives us minus x evaluated from t to 1. Okay, what should we do next? Well, we realize now when we plug in the limits and then we allow t to go to 0, we have a problem. So what we need to do instead is we're going to plug in t and then put it into a format where we can use L'Hopital's rule so we can evaluate it properly. So let's do that. So we have the limit as t goes to 0 of, plug in the upper limit, we get 1 times the natural log of 1, minus when plug in the lower limit, we get t times the natural log of t, minus, here we plug in the upper limit, we get 1, minus when plug in the lower limit, we get t. So we're okay with evaluating this. This is equal to 0. Evaluating this, because when t goes to 0, this becomes negative 1. But what do we do here? Well, we're going to rewrite that into a fraction format by writing this as 1 over t in the denominator. So this is going to be written as the limit as t goes to 0 of, well, this is already 0, so we don't need to repeat that. This can be written as minus the natural log of t over 1 divided by t. So I'm bringing the t to the denominator and writing as an inverse. And then this here would be minus the quantity 1 minus t. Now I can take the derivative of both the numerator and the denominator. When I take the derivative, I get the following. So this is the limit as t approaches 0 of the derivative of the natural log of t would be 1 over t, so it would be minus 1 over t, divided by the derivative of 1 over t would be minus 1 over t squared. And of course, the two negatives cancel out. And over here, I still have a minus 1 minus t. Of course, this reduces to just t. So this becomes equal to the limit as t approaches 0 of t minus 1 minus t. And now I can go ahead and evaluate that when I plug in the limit t equals 0, because then I get 0 minus 1 minus 0, which is equal to minus 1. So the undefined portion would eventually go to 0. However, we could not tell by doing it directly, by plugging in the limits directly. We're going to first plug in the limit of t, then you use L'Hopital's rule. So put into a fraction format, we can use L'Hopital's rule in order to get into a format where we can now legally, without problems, evaluate it for t becoming 0, and then we realize the final answer is -1, which represents the area here underneath the curve. And that's how it's done.